Hello, my name is Trevor Haney, and my favorite candy bar is a Twix bar. Here's a picture of me in London, in Trevor's place. I found that while walking around Westminster this past summer. And the other picture is when I was still student teaching. I graduated from Millersville in 2014 with a tech ed degree. After college, I taught at Westminster, Maryland, for a year before returning back to PA, and I've been teaching at Oxford Area High School for the past 3 years, teaching grades 9 through 12. I teach all of our Project Lead the Way courses at the high school, which includes Introduction to Engineering Design, Principles of Engineering, Aerospace Engineering, and Civil and Architectural Engineering. Along with being in the classroom, I'm also the current head track coach, focusing on the long jump, triple jump, and pole vault. I'm also the ski and snowboard advisor, the ping pong club advisor, and the STEM advisor. To the right, here's a picture of me running it at our recent 5K that happened about 2 weeks ago. I came in third place overall. I had to show up some of the track kids. And just below that is our current STEM team members, and this is a picture right after we had gotten second place in the governor's STEM competition this past year. So, how do students learn science? Students learn science in a multitude of different ways, as explained in the Donovan and Bransford text illustrated in chapter 1 and 9. There's different ways of learning. When it comes to learning science, there's many different preconceptions on how the world works. And if a student is not taught and not introduced to real-world problems and understand how to apply their knowledge, thoughts, and ideas when you need to really question if learning actually occurred. From the text, page 403, the author brings up the point that, to quote, "We have noticed that in the past, teaching the process, not just the outcome of science, often involves no more than memorizing and reproducing the steps of an experiment." End quote. I have many students who talk about science class in my room, and they couldn't tell you what the experiments are trying to explain or what they're trying to do with the activity, and instead only plug in numbers from their experiment, and as long as they receive a decent grade, they're fine with it. To really learn science, students need to be immersed into the science world and understand the process of science, versus just the outcome. Today, many students only understand science as right and wrong, and do not include imagination or thought into their work. They want a clear-cut answer, which isn't always the case with science. So barriers in science learning. As explained before, there's many different ways of learning, and that means there's many barriers to learning as well. Some students have never had a hands-on real-world approach to learning, and some concepts are not fully explained to each student in the method that they need. As explained in the Donovan and Bransford text in chapter 1, page 5, that is, infants from 3 to 4 months are able to understand some principles of static elements and Newton's basic laws of motion. However, when they get to middle school and high school, find it hard to grasp those basic principles. Students also throughout school learn and understand concepts to only forget about them a week later after they have taken a test. This method of learning is not ideal in a real-world environment. If students' foundations are not strong, then the students are being set up for failure. So how does my classroom adhere to the tenets of science learning described in the model reading? I try my best to teach real-world problems where the students will need to completely understand a topic to complete a task. The students mostly apply what they learn in other classes and utilize the knowledge to complete a task in my class. Like in Fish is a Fish story, a lot of my students come in to class and they know how to do the math and science type problems. However, they're unable to actually apply the knowledge to a real life problem. That is kind of what my classroom is used for and how I try to teach my kids. I really enjoy seeing the students' faces when they see how their math and science courses can actually apply to everyday life. Here is an example of my student's hydroponic system. The lettuce was alive and well, and then it all started to die. Instead of stepping in and trying to stop the plants from dying, we had the time to let them just die. And the students learned more about how and why they died than just making sure that the system worked. Students were able to understand root rot and how to prevent it in the system on their next attempt. And in each iteration, the plants have become better and better throughout the year. So my STEM perspective is leaning towards transdisciplinary approach where all subjects work together. I teach mostly project lead the way courses, and though I focus a lot of my attention on the engineering and technology side, I know better. And I still, at times, need to cover math and science skills. I think they all need to be completely mixed together to make it as beneficial as possible for the students. The students should feel like some days are math, or they shouldn't feel like some days are math or science or engineering days, but instead come to class ready to learn STEM and apply their knowledge.